Hello everyone, welcome back. In the previous video, we saw the process of mapping the logical perspective or logical representation of a linked list data structure into a program. We basically implemented our own single linked list data structure. We also executed two operations. We traversed over the items of the linked list and we printed each element, data portion of each element or each node. We also implemented a function to insert at the end of the linked list. In this video, we will explore the method of inserting an item at the beginning of the linked list. So this operation is going to be super simple. As we saw in the previous video, when we create our linked list, we maintain two pointers: a head pointer pointing to the first element or the head element of the linked list, and a tail pointer pointing to the last element of the linked list. So to insert an item at the beginning of the linked list, so initially we have head pointer and also tail pointer, both of them pointing to null initially. Null, this also points to null. So to insert at the beginning of the linked list, the first step is to create a new node having the data we want to insert at the data part of the new node. Say I want to insert number 3 in this new node, and say this new node having an address 600. Initially, the next pointer of this new node is going to point to null. So first I'm going to check if my list is empty. And if the list is empty, what I'm going to do is I will make head pointer point to this newly created node, and also null pointer point to this newly created node. So let's define a function so that every time it can check for us if the linked list is empty or not. So I'm going to call it public boolean. This function is going to return true or false. Let's call it as empty. And this function is going to return true if the list is empty, otherwise it's going to return false. So it returns if the head is equal to null, it will return true, otherwise it will return false. I'm also going to upload the source code of this project to the GitHub, and I'll provide the link to this code at the description of this video. If you guys want to download the code, you can do that. So let's define another function, public void insert at beginning. This is also going to take an integer type data. So first I'm going to check if is empty. If my linked list is empty, what I'm going to do is I will set the head pointer, this dot head equal to this dot tail equal to so before that, let's create a new node, new node equal to new node, and we pass the data. So it will set this data to the data part of this node, and also this constructor is going to set the next pointer of this newly created node to null. So I'm going to set head and tail to this newly created node, a new node. But if the list is not empty, we are going to do something else. So let's say I created this newly node, head is pointing here and tail is pointing here. So head and tail is no more pointing to the null, and our linked list is not empty. Say I want to insert another item. Say I want to insert number 8 at the beginning of this linked list. First I'm going to create the node, insert number 8. This is going to point to null. Say this one has 100, address 100. What I'm gonna do is I will set the next pointer of this newly created node. So I'm gonna call it NN or new node. So I will set the next pointer of this newly created node to point to the head. So initially head is pointing to address 600. I will also make the next pointer of the newly created node to point to the head. So I will store address 600 to the next pointer of this newly created node. So this way a link is created between the head and the tail. So we are not done yet. The next step is to update the head pointer, since this newly created node is going to be our head. So the next step is to update our new pointer. Instead of head pointing to this previous node, we will move and make the head pointer point to this newly created node. So we don't want to touch the tail pointer. Tail pointer is going to remain here, since we are not inserting at the end of the linked list, every time we insert at the beginning, we update the head pointer only. We don't touch the tail pointer. The tail pointer is indicating the tail or the end of the linked list. Since this node's next pointer points to the null, this indicates the tail or the end of the list. Okay, so let's do that. What I'm gonna do is first I checked if the list is empty. I set head and tail point to the new node. Else what I'm gonna do is I will set the new node's next pointer to point to head. So I will say new node dot next equal to new node not new node to head. Then I will update the head to point to the new node. So this dot head equal to the new node. So this way we can easily insert at the beginning of the list. So let's check and test our function. So I'm gonna go to the main function. So this time I'm going to call list dot insert at the beginning. So I'm gonna insert number, say I want to insert number 10 at the beginning of my linked list. Initially the beginning of the linked list was number 3. So this time if I print, number 10 should be the beginning of the linked list. As we can see, number 10 is the beginning of the linked list. Say I want to insert a number 100 at the beginning of the linked list, so it should work. Yeah, number 100 is at the beginning of the linked list. To calculate the time complexity of inserting at the beginning of the linked list, as we saw in the previous video, every time we insert at the beginning of the linked list, we are not looping, we are just simply reassigning some pointers. So always inserting at the beginning of the linked list is going to have big O of 1 or constant time complexity, because this is going to take constant time or big O of 1. This function also takes constant time. This is also going to take constant time, constant time, constant time, constant time, and constant time. We don't have a loop inside this function, so the overall if big O of if we calculate all the constant time, say we got big O of say 6. Again, we saw that all the constant times are dropped, and we finalize this big O notation to big O of 1 or constant time complexity. So the time complexity of inserting an item at the beginning of the linked list is going to be big O of 1 or constant. Thank you guys for watching, and see you in the next video. Bye bye.